Life on the sea floor can be a challenge. Limited by an inability to migrate large distances, demersal creatures must find ways to survive using resources available on the bottom. But one peculiar group of creatures has adapted to make the most of this way of life. The Echinoderms, meaning spiny skins, dominate the sea floor. A diverse phylum that contains starfish, sea urchins, crinoids and sea cucumbers, creatures that might seem very different but in fact share many traits, while they each fulfill their own important niche in the ecosystem. Without them, the biodiversity of the oceans would be far less staggering. Let's find out why echinoderms are so significant. Echinoderms come in countless shapes and sizes, but there are a few unique features that unite the 6,500 living species. Many adults of this phylum have five-way radial symmetry, a pattern most prominent in the shape of the starfish. In addition, they have skeletons made up of interlocking calcium carbonate plates and spines called ossicles. This provides rigidity for their complex structures, making up the protective shell of urchins, or the column-like spine of crinoids. These skeletons are also the reason why fossils for echinoderms are so widespread and well preserved, with some crinoid fossils being as old as 500 million years. Perhaps the most peculiar creatures of this phylum are the holothurians, sea cucumbers with their retractable feeding tentacles and tube feet around the mouth, which they use to forage in the seafloor mud. One deep-sea species, the swimming sea cucumber, is very different from its more worm-like shallow water relatives. This species has a wing-like flange and a much more gelatinous body, allowing it to ascend from the sea floor and swim for short periods of time. It can therefore cover large distances in search of food before landing and using its oral tentacles to shovel sediment into its mouth with voracious appetite. It then vents the processed sediment behind itself, much like an earthworm, before taking off into the dark above. In doing so, the sea cucumber cleans and aerates the sediment, excreting inorganic nitrogen and phosphorus that enhances the benthic habitat. All sea cucumbers serve a useful role by recycling nutrients in this way, breaking down detritus into a form that's more accessible to bacteria and smaller creatures, and less likely to cause algal blooms that cause fish to suffer from lack of oxygen. Without holothurians acting as engineers of the marine ecosystem, the seafloor would become barren. At around 4,900 meters or 16,000 feet down in the abyss of the ocean, one of the deepest living holothurians can be found, the sea pig, cleaning up the organic material that sinks from the water above. Showers of marine snow and sunken carcasses. They are known to act as valiant guardians for juveniles of another creature altogether. Baby king crabs, who cling onto their gelatinous protectors as a mobile form of shelter from the many predators that stalk the deep-sea benthos. A number of sea cucumbers are plankton feeders, extending feathered tentacles into the water as a net for passing microorganisms. It then licks these tentacles one by one with a central mouth. But the importance of holothurians is not limited to their role as detrivores and filter feeders. Many burrow down into the seabed, causing bioturbation, restructuring the sediment in a way that allows other species to flourish. Others take part in complex symbiotic relationships with different species. For example, emperor shrimps live on the bodies of shallow water species, eating parasites in return for protection, a form of mutualism where both species benefit. The slender eel-like pearlfish often lives inside sea cucumbers, benefiting from being sheltered by the holothurian. The host gets nothing in return, making this an example of commensalism. Living within a sea cucumber is a clever behavior, for they are well adapted for defense, discharging sticky threads called Cuvierian tubules to deter and ensnare predators. Others mutilate their own bodies or expel their internal organs out through their anus, a move likely to put off any hungry crab or sea turtle. In fact, one of the only predators capable of handling the sea cucumber's defenses is yet another species of echinoderm giant sunstars of the North Pacific. Starfish, or sea stars, are widespread, inhabiting shallows in the tropics as well as the depths of Antarctica. Like holothurians, tiny tube feet line their underside and allow them to traverse the seafloor in search of clams and oysters. One species, known as the crown of thorns, is able to digest living coral by wrapping itself around a colony, inverting its stomach out of its mouth and leaving behind a bleached, lifeless skeleton. A process that can maintain reef diversity by preventing fast-growing coral from overpowering slower-growing varieties. But studies have shown that climate change can lead to overpopulation of the crown of thorns, causing entire reefs to be devastated. This demonstrates that when an ecosystem loses its fragile equilibrium, stability is lost and biodiversity suffers. Sea urchins are another culprit for reef destruction. But once again, the issue is not their existence, but an offset in the stability of reef species. Under normal conditions, urchins are important herbivores that play a key role in maintaining a balance between coral and algae. If they were to go extinct, reefs would be overwhelmed with algae and seaweed and eventually die, while predators like the sea otter would be at risk of extinction, for urchins are their main source of food. Bearing some resemblance to starfish, brittle stars are their thinner, more agile relatives. Starfish rely on a water vascular system to move, forcing water into their tube feet to stiffen them and move along like a conveyor belt. Some brittle stars, on the other hand, also twist and bend their long arms to move, allowing them to travel more quickly and even take to the open ocean. Basket stars are a unique group of brittle stars found clinging to the continental shelf as far south as Antarctica. Filter feeders that crawl to the tops of sponges or rocky structures in order to extend their branched arms into the water column. They have been known to catch krill and small fish in their tentacles in addition to plankton. Their presence in Antarctic waters is an important factor that supports the ecology of the polar deep, upholding biodiversity and maintaining balance, as is the case in nearly all locations where echinoderms are found. Creatures of the marine world rely on each other for food, protection and stability. Echinoderms are in many ways bastions of the ecosystem. But with human activity causing the marine ecosystem to undergo catastrophic changes, the biological niches occupied by creatures like holothurians and starfish can no longer support marine ecology to the same extent. Their roles in nutrient cycling, predation, symbiosis, and keeping ecological factors like algae in check are under threat. By extension, life in the oceans is continuing to deteriorate.